There are thousands of suppliers with millions of products, but you still can't always find what you need right off of that shelf. Why? Because your projects and their products, they vary. Sometimes you need that customized solution, but above all else, you can't forget about the precision, especially if you're in the world of metrology. And in the 1940s, air gauging took this industry by storm. It brought metrology to another level. What is air gauging? You and I both ask ourselves. It's a process that you utilize on features that have 3000s tolerance or even under, going into the millions. And it's especially a process that you look into when you're trying to look at the level of operator influence in your quality control process. So, what is air gauging? How do we use it? And honestly, when do we not? These are all questions I had the privilege to ask the team here at Mahr, the leadership team. They invited us in, they invited the how-to team in to their facility, Mahr Inc. in Providence, Rhode Island, where we're gonna be answering those questions, many more, and you and I are gonna be learning how to simplify complex measurements. Now this is some stuff you can't just get off the shelf. How's it going on, brother?
Good morning.
Farzad. All right, man. This episode's all about simplifying complex measurements. This looks like a complex system, complex part. Simplify all of this for me, man. I need it.
This is an engine block, and what you see here is a gauging station that uses different types of gauges.
Okay.
For example, what we have here is a contact gauge, which uses actual mechanical contacts to measure the diameter or gauge the diameter of the bore. But what we have here is another type of gauge, but this one is a non-contact air gauge, air plug, and that also can be used to check and gauge the bores, IDs and ODs of this complex part that you can see here with a lot of IDs and ODs.
And I heard you say that this is a non-contact measurement tool, but here I am putting the measurement tool inside of the bore.
Yes, let me clarify on that. With the bore gauge or the mechanical gauge, the actual measurement values actually come from the mechanical contacts. Yeah. But in an air gauge, the sensors are actually these air jets, and these don't touch the surface of the part.
Interesting.
And that's why we call them non-contact. But the body of the plug, yes, that will touch the part.
That's starting to make some sense for me. So I know air gauging's been around for 80 years. Can we go see what else you have going on?
Absolutely.
I gotta learn more about this, man. Gotta wrap my head around it. All right, man, it looks like we're still in the automotive industry. What do you got for me over here?
This is a good example of air gauging. This is a crankshaft, and this gauge here is what we call an air gauge snap, air snap. Perfect gauge for this type of tools where you want to check the part while they're still on the machine.
Mm-hmm. If I was a lathe operator, take this tool, go into my machine with my setup still intact. Let's just pick this feature right here. I would check this to see if A, it's good, or B, if I need to take off a thou, half a thou in my machine, not messing with anything, any of my processes, getting it done. All right, you said you got one more cell to show me. Let's go see what it is. Now this is a table that shows some variety, man. I hear some air going. I know we're gonna see some action, but give me a rundown, A to Z. What do we have going on at this table?
What I want to start with is I'm going to start with the air plugs. Mm-hmm. We can make air plugs that are 2 millimeters in diameter, and we can go. That's an example of an 8-inch air plug,
but we can go gauge that you would put inside. What else we got?
So that's the standard different sizes of air plugs. We have long range air plugs. These are used in the oil industry for pump barrels. Okay. So these have the extended range of plus or minus 0.005 of an inch.
That's sweet.
And then we also have air plugs with more than 2 jets. These are 6 jets that will work for average diameter, for example.
So is the increased number of jets similar to how, like, if I'm on a CMM or something and I'm adding points to check along my part, it increases like your accuracy?
Correct.
Is that the same for you guys?
Yes.
Nice.
For machine tool holders, we have this tapered air ring here, and that's a sample part.
Nice.
So that's a good example if they want to measure or check their the parts. Here you can do the checks on the taper angle, as well as, well, in this case, 4 different diameters along the different gauging lengths.
Nice.
So that's another example application.
So brother, we've hit on the complexity of processes, of parts, and how air gauging can simplify that. I love all this. I think we have some more work to do downstairs or
Correct.
something. You mind us going to check that out?
No, please.
I'll say this is the first time that I've been at an underground education session. Everybody's invited. How's it going? Hey. John? Yes, sir.
Jacob, how you doing?
We got Scott. How's it going, brother? You're hard at work. I won't interrupt you too much. So this is an education session all about using air gauging to make air gauging. What do we got going on down here? I heard that this is the honing area.
Right, exactly. So this is our honing department, and just like you said, we're using an air tool to measure air tools. So what he's doing right now is he's honing open a bore to size, and then we've got an air gauge over here to measure the size to make sure he's good.
I heard honing, and at least like in my world, for my table, for example, I'll get a stone, I'll do grinding, I'll do stoning, called it honing. We're trying to get that surface flat. Is like the same principle kind of apply over
Exactly,
here?
that's exactly right. So this is a stoning process. So there's an actual stone that spins, and that's what's opening up the bore. And what's nice about this process is it's very accurate. So in this case, the particular part he's working on has a +0 -6/10 tolerance. So he'll master his air plug and then check the bore as he goes to make sure he's to size.
Why am I not just checking it with a go, no-go pin? Because you can get those down to, what, 2.5 tenths to check that diameter. Why am I not doing that?
Well, because the go, no-go gauge tells you if your part is bad or good. But what air gauging, Mahr air gauging tells you is how much you deviate from your nominal. It gives you more information about the form and size of the part. When you explore the part, when you insert the air plug and move along the bore, that's basically kind of you're exploring the size along the axis.
And his honing's a dirty process. You know, you got oils, you got debris. When you use an air tool, the air tool itself will act as your blowgun, so you can blow away your debris and your oils. You don't need to worry about your part being perfectly clean to measure, you know, down to the tenths.
That's interesting. I appreciate the work that people like Scott put in every day, because that does look a little dirty. But I heard that you two got something else that we need to check out. All I was told was giant plate, air gauge in the middle. Could we go see it?
Absolutely.
Thanks, man. Even at the end of the day, y'all still got some surprises waiting for me. What do we got going on?
Here is just another example of how we use air gauging in our facility, another workstation.
I see literally no air gauging whatsoever.
Well,
Oh, I hear it. There we go.
Yeah.
So what's going on with this? This is a actual product you make here on site?
That's right. So this is a granite surface plate with a single jet air probe sticking out. And what that's doing is we can use this to measure flatness. So we've got a part here that's fresh off the surface grinder, and we can use this little gauge here to measure how flat we are.
And right now it's showing me what, 8 thou out of?
It's 40 millionths is where you are right now.
Oh, geez. I'm missing a few zeros. So this is awesome. Usually what I would do, and correct me if I'm wrong, if I'm checking flatness in my facility, I still got my big granite, still have my part, but I have to actually use like a dial gauge or a jeweler's gauge to run across.
Sure, that's another option. Yeah.
Flatness,
that's another option. What you get from the benefit of this, though, is that, like those other examples, you have contact. So that means you have to have an actual point contacting the part, whereas this, the probe is recessed below the granite, so it doesn't touch the part at all, so you don't have to worry about scratches or anything else. It's non-contact to the part.
So after seeing this, I want to do a little play with both of you real quick. So I am an owner of a automotive machine shop. Let's use that engine manifold for an example. What's some of the first steps that we're going through that we've kind of seen today in your own words?
Well, the first step is for us to have the official print of your part. Once I have your print here, then the engineering team and design team will review the print and We'll make sure that your need is within the application of air gauging. Once that is confirmed, then we will have a meeting with you and to discuss the details. Would you like your gauges to be handheld or fixtured or base mounted? Anything that can be discussed. And then once that those things are settled, then we can, actually go ahead with the quote and production.
So what I heard there is I come to you, I give you my part, this is what I'm making, this is what I'm machining in my facility. I heard you say we don't pigeonhole you, because a lot of the times what we're doing, it has to be customized at least a little to our process. What's something that you would throw in there?
We make little benchtop gauges like this, all the way up to large systems that can, a turnkey type system that can be an entire room.
You're talking automation stuff as well.
Exactly. Right.
Interesting. Guys, I appreciate the time that you've spent with me today, that you spend for all of your customers. Look, at the end of the day, what it all boils down to is simplification. It's about taking these complex features that are in our parts, the things that we're machining in our shops for our customers, for the world, and figuring out ways that we just haven't done it before. And it's about also rummaging through all of the different supplies out there, all the different ways to do the same thing, and just simplifying it. Above all else, it's about learning how to simplify complex measurements.
For more metalworking tips and industry best practices, stay tuned for the next how-to episode and subscribe to the MSC Industrial Supply YouTube channel, a source of original manufacturing content built to make you better.